Did you know that the first EV was made in 1832? And by 1900, EVs had become more popular than petrol and diesel engine vehicles. But then something happened that all EVs vanished from the market. But now EVs are becoming popular once again, and they have started capturing the market. From the world's biggest companies to many small and new companies are making EVs, those who had never even made a car before. See, the concept of EV is not something new. In 1821, Michael Faraday first discovered that when a wire gets current from a battery, it rotates around a magnet. This was the first time electrical energy was converted into mechanical energy. Then this concept became reality, giving birth to the electric motor. And in 1832, Robert Anderson built the first electric vehicle. It was an electric carriage that used non-rechargeable batteries, meaning they had to be replaced after a single use. So it was kind of an experiment. Back then, EV's biggest problem was the same as today, the battery. Then, in 1859, a French inventor invented the rechargeable lead-acid battery. This invention solved the single-use battery problem. Now we could store electricity in the battery. We could use it, and then recharge the battery once again. Along with this, electric motor tech was improving rapidly. Then, in 1884, Thomas Parker built the first production EV. It used rechargeable batteries. But the first practical EV arrived in 1888, the Flocken Elektrowagen. It was a four-wheel wooden carriage. It had a 1-horsepower electric motor that powered the rear wheels. A lead-acid battery was used to provide power to this motor. The car's top speed was 15 kilometers per hour. Then, in 1890, William Morrison's electric wagon arrived, and with it, electric vehicles started becoming popular very fast. By around 1900, 1/3 of the cars running on U.S. roads were electric. The advantage of electric cars was that they didn't need a hand crank to start them up. They also produced less noise and pollution. That's why people liked them so much. This era was the first golden era of electric cars, but it didn't last very long. In 1908 came the Ford Model T, an internal combustion engine car. It wasn't the first car, but it was the car that changed the world of cars and wiped electric cars out of the market. Actually, back then every car was custom built, needing skilled workers and lots of time, making cars very expensive. Ford introduced assembly line production, where the car stayed still while workers assembled parts in a fixed sequence. This increased manufacturing speed and reduced costs. Then, in 1913, Henry Ford introduced the moving assembly line. A conveyor belt system was used, so car chassis moved slowly to one end of the line, with each station having a specific job. One worker fitted the engine, another the wheels, the third seats, and so on for all other parts. With this chain, production time dropped from 12.5 hours to just 1.5 hours. This was the mass production revolution, making the Model T the most affordable car. The highlights of IC engines were range, high speed, and the easy availability of fuel. Electric cars had limited range. Long charging times and heavy lead-acid batteries affected their practicality. By the 1930s, electric cars almost vanished from the market. Petrol and diesel cars captured the entire market. But after 1990, as pollution and fuel crisis issues grew, car manufacturers began focusing on EVs again. Companies started working on battery tech. And after 2000, lithium-ion batteries completely changed the game. Then in 2003 came Tesla Motors, proving EVs could be high-performance vehicles. And in 2008, they launched Tesla Roadster. This car used lithium-ion batteries and had a 393-kilometer range, 0 to 60 under 4 seconds, and a top speed of 201 kilometers per hour. All this was previously unimaginable for electric vehicles. After this, interest in EVs grew among other automakers, and with the Nissan Leaf, affordable EVs began. And today, almost every car company is making EVs. That was the evolution of EVs. Now let's look at the main differences between an EV and an IC engine car. An EV uses an AC motor to rotate the wheels. This motor consists of two main components. First is the stator, and second is the rotor. The stator is the part that remains fixed, and the rotor is the part that rotates. When current is supplied to the stator, it generates a rotating magnetic field. This causes the rotor to rotate, and we get the required rotating motion. But in an IC engine, we don't get rotating motion quite as easily as that. In an IC engine, we ignite an air-fuel mixture to move the piston up and down. Then, we use a crankshaft to convert the piston's reciprocating motion into rotational motion, meaning an IC engine has many more parts compared to an EV just to generate rotating motion. And the more parts there are, the lower the efficiency. More moving parts also mean more vibrations. Modern engines control these vibrations to a great extent, but still not as much as an EV. Now let's talk about power control. In an IC engine car, you control speed by adjusting air-fuel supply with a throttle. But in an EV, there is no air-fuel supply. It has an electric motor instead. In an EV, voltage is regulated to control the speed of the motor. When voltage supply increases, speed goes up, and when it decreases, speed goes down. Next, let's talk about transmission. In an IC engine, you see many different types of transmissions, like manual, AT, DCT, etc. These have multiple gears inside, making the transmission bulky and heavy. But an EV doesn't have such heavy transmission. EVs mostly use a single-speed transmission. Some performance EVs do use 2- or 3-speed transmissions. Why is just one gear enough for an EV? I have already made a video about that. You can find the video link in the I button and the description below. For now, just know that an EV motor delivers peak torque right from 0 RPM, while an IC engine provides peak torque only at a specific RPM range. And that's why you get better torque in an EV compared to an IC engine car. Since IC engines have more parts, they also add a lot more weight. To deliver power to wheels, many parts besides the engine and transmission increase the weight. But weight is also added to EVs by batteries. To increase range, a bigger, heavier battery is needed. Since the battery supplies DC and the motor needs AC, an inverter is needed to convert DC to AC. So an EV requires a motor, a battery, an inverter, and a compact transmission, whereas an ICE car needs an engine, a transmission, and a fuel tank. So an EV's weight is usually equal to or even more than an ICE car's weight. One advantage of EVs is that the battery is on the floor and the motor's transmission are compact. Thus, you get better cabin space in an EV compared to an internal combustion engine car. Now, let's talk about maintenance for both. An EV doesn't have an engine, so engine maintenance like oil changes, spark plugs, injectors, and gaskets is greatly reduced. But you still need coolant in an EV. In ICE, coolant controls the engine's temperature, while in an EV, the coolant maintains the temperature of the battery and the motor. There are other common maintenance tasks you need to do for both EV and ICE cars, like brake pads, brake fluid, transmission oil, and many small things common to both cars. But there's one thing considered a major disadvantage for EVs, and that is the EV battery. Like any battery, an EV battery degrades over time and must be replaced after its life ends. Typically, an EV's battery life is 8 to 15 years, as stated by the companies. But the battery replacement cost is very high, enough to buy a small new car. And if you sell an EV after 8 to 10 years, the new owner will need a battery, which is very costly. And that is why the resale value of an EV is usually quite low. So let's end this video here. Do share your thoughts about EVs and ICE cars in the comments. And if you found this video informative, please like, share, and subscribe to the channel. See you in the next video. Until then, have a nice day.